Hello, everyone. So my name is Aviel. Like Adam said, I work at Adobe, at the Bēhance team. Don't worry if you don't know it, it's fine. I'm not going to talk about it here. And like he said, I was supposed to be here last year in 2022. That didn't work out. I'm going to explain why in a second. But before I explain why, first of all, I use all the social crap, so just pick one. I don't care which one, they're all the same. There's going to be a document in the end that I'm going to essentially give you like a QR code for a PDF with everything I'm going to say here and much more, so you don't need to feel like you need to take notes or anything like that. Don't worry about that. And my talk is about two things. I'm going to start by talking about the philosophy behind SwiftUI and how things work, how views are getting diffed when you have a change in your state. And then I'm going to show you how you can use that to build great apps and kind of like best practices and tips for SwiftUI performance. Like I said, before I start with that, I have some explanation to do. So last year, I was here 2 days before the conference, and I saw a playground, and I thought, oh, this is fun. I can hang upside down. Then when I was like this, I realized I'm not sure how to go get down from here. And I tried, and then it didn't work out. And I also, so I did some tests, I did some X-ray and some CD and some stuff. I had the best food I ever had in my entire life, amazing food. And I broke my skull here in the back. So if you were like, come on, he just fell from a swing, like he couldn't like come to do his talk. No, I could not. So that's that. Now that we have that behind us, let's move on to SwiftUI. So Apple, if you kind of ask Apple to summarize like TLDR, SwiftUI into a single sentence, they would probably, I'm guessing, I have no idea. I have no connections with Alex. They would probably say this is about views as a function of state. And I even brought Luca from the SwiftUI team all the way here to tell you himself.
View are a function of state.
Exactly. If you missed that, let's hear that again, because it's very, very important.
View are a function of state.
Great. Very, big sentence, right? What the heck does that mean? And more importantly, how can this help us when we write UI code, and how can it help us write UI code faster? So when you switch from UIKit to SwiftUI, there is kind of like a change in your mind that you need to make, and it's almost like a new science and a new way of thinking. And so it's sort of like a journey for your brain, from imperative thinking to declarative thinking. The sad part is that this journey is not that easy, always. This is a US joke, I think, so when I did this talk in Denver, I got more laughs out of it. So let's start with good old UIKit before we transition to SwiftUI. So in UIKit, we have view controllers and the UI views, and they are long-lived, and you can kind of call them the king and the queen of the situation. And then you have events that are passed imperatively. Any change in this state, you explicitly change the view, and you tell whatever delegates that care about. And in the end, those delegates, all they do is tell someone else to change some other state and change some other view. And everything happens explicitly, and you have to think about all of those cases yourself. So you have this UI view controller, and it coordinates everything. Everything is long-lived. You keep references, either for performance, you want to keep some views alive, or for navigation, etc. You have your views and your view controllers who know their state, and they know their layout size, and they do their own event passing. Then came SwiftUI. In SwiftUI, everything changed completely. So we have the state, and state is king. There's no queen. And we have those views, and you can see those views are kind of like half transparent. That's because the views are very different from UIKit views, almost not related at all. It's almost like templates for something, not like solid, like a UIKit view. And there is no delegates and no view controller at all, anywhere here. So if you compare that to UIKit, we just do not have a view controller at all. The views are short-lived. They always recreate them many, many times. References just make no sense. Even if views in SwiftUI were a class and not a struct, it would still make no sense to keep a reference to a view because they are recreated all the time. They don't own the state, not even at state. And they don't know their size, but they control their size. And there are no events. You only mutate your state, usually. So the big question is why, right? And the answer to that question, or kind of like the core, the root of the problem here, is that it's really, really, really hard to keep your state and your views in sync. One very known problem is when you rotate your screen. iOS actually handles this pretty well. But for example, on Android, if anyone here is an Android engineer, and I know some of you are, Android just kills the entire screen. It's called activity in Android. It's imagine like your UI view controller, just de-init and init from scratch, and everything happens from scratch, the entire screen, for doing this rotation to sync the state and the view. Maybe they changed it since I last worked on Android. I didn't work on Android for a while. So yeah, just avoiding any unexpected effects is really, really hard when you control both the view and the state, and it's on you to coordinate between those changes. So what can we do? One thing we can do is brute force. We can, flash everything and recreate everything, like I said with the example with Android, when you rotate a device. Or the another approach is we can try the declarative approach. And the declarative approach has a couple of philosophical ideas. First of all, we change the state. We never change the view. And then the other thing is that the view will subscribe or depend on some state, right? And essentially, the view decides, these are the things I care about when I need to render myself. How does that work in practice? So let's say we have this tree, graph, whatever you want to call it, of views. Those are the orange rectangles. And then we have some states associated with those views. And you can see I'm saying associated, not owned by those views, because again, the views do not own the state. SwiftUI does. So we have states associated by the views. And then some state changes. We have new dependencies, new state. The first thing that we do, or SwiftUI does for us, is that it will create the new view with the new state and compare that to the existing state. And well, you're going to see later exactly how SwiftUI compares between states of views. But for now, let's just assume it just compares somehow and checks whether they are equal. If they are, that's it. We throw the new view to the trash. We don't do anything. We do not render anything on the screen. If they're not, we call the body of those views. That's the second thing, the second step. And we check whether the bodies are equal. And if you think about it, the body is just creating the views that we create inside the body of this view. So it's just creating more views in the end and checking if those changed. And then we compare them. Again, if they're not, if they're the same, we just throw it in the trash and we keep whatever we had on the screen before. Only if they are different, only then we grab the new view, put it on the view tree, render the changes, and throw away the old one. So you can kind of imagine, and this is now we're getting back to Luca finally, you can kind of imagine views in SwiftUI really as a function of state. It's actually more like two functions, but that's OK, we can forgive Luca. The first function is state and dependencies, which is essentially everything the view cares about, everything the view needs to render, and then body for a given state, which is give me some state, and I can give you the body of that view. You might ask yourself, where does the business logic go? Doing things in the app, sort of to nowhere, or more accurately, it goes somewhere, but not in the view. And so if we go back again to UIKit, view controllers used to have two kinds of logic, right? They pass events and they pass changes between the views. And then the second thing they do is they handle data, like basically called CRUD. In SwiftUI, the first one is just redundant, because now we just change the state, and the view just is whatever needs to be rendered is now rendered for us. And number two, should never live in the view controller. If you know massive view controller, that kind of started from us doing number 2 inside the view controller. And so now Apple is basically forcing us to put it somewhere else. So you can imagine some random app this is kind of like an imaginary hierarchy or architecture of some app. And you have some navigation router, and you have like a user store, and some feed, manager, provider, whatever. And you can see they are all at the top. They all do not care about the UI. And then the UI just depends on whatever it cares about. And none of the UI owns any of those entities. So now let's talk about performance. Now that we have kind of like a high-level idea of how SwiftUI works and how the views are getting rendered. So when I say performance, I actually break it into 3 things. The first one is less diffing, which means that step A, step B I showed you, which is comparing between 2 views, obviously takes time, and we want to do it not too many times. And then the second is fast diffing. So when we already diff between different views, we want that to be as fast as possible, right? And number 3 is expected behavior. When we write code, we want it to do what we think it's supposed to be doing. And if you worked with SwiftUI, when you get started with SwiftUI, many times it does not look like you expect. And then you realize, oh, the modifier was supposed to be over there. The geometry reader just destroyed my layout, blah, blah, blah. And so we want to make sure that we get what we want or what we expect. And so I added these badges. And for whenever something happens, or for anything I want to talk about, it will show here in the corner how it affects or what it's actually affecting. So the first one is keeping your view body simple. So in your body, in the end, you just need to provide some view. Technically, you can do anything you want to provide that view, but you want to avoid doing any complicated work inside your body of the view. So on the left, you can see that we have some data that we need to get in the end, and we're doing a chain of actions, probably not getting it from the server, because that's really bad, but maybe sorting or filtering or mapping it somehow or parsing or whatever. And instead, what we can do is we can take it out into some other entity, some other object, and only when it's ready, we can give it to the body. And then all the body does is present it. And the reason this is important is because the system can actually call your body multiple times in a single layout phase. So you think, oh, I changed something. My body is going to call it once, and I'm going to get a view rendered. No, your body might be called twice, 3 times, 4 times to render a single frame. So you really want the body to be really, really fast and not do any logic or anything complicated. So for example, this is kind of like an obvious example. Let's imagine that you have some cupcake view, and you're presenting some cupcakes, and you want to sort those cupcakes maybe based on how the flavor or the price or whatever, or what you have in stock. And the sort is very complicated. And so you could do it like that, and it's going to work. But instead, what you can do, which is probably much better, you can have some sort of cupcakes provider. And inside that cupcakes provider, you fetch the items from your backend or wherever. You sort your cupcakes however you want. And only in the end, you have this published variable that is going to update the UI. So in here, we now grab the provider. We create the provider as a state object. And we grab the cupcakes from the provider. And when we are about to present the view, we ask to provide the items. And by the way, .task, you might say, oh, but I support iOS 14. OnAppear is exactly the same as .task, for those who didn't know. It does not actually called OnAppear. It's more like view did load, technically. It is definitely called before your view appears. So you can definitely do things like that are async before your view appears. You don't need to worry about that. So you can just do OnAppear just as well here. Task only cancels your task if the view gets out of the tree before the task is complete. That's the only thing task does differently. If you're using observation, if you're one of the rare lucky ones, I don't know if there's a single person here in the room that can support 17+, but if you are, then this is this is how it looks with observation, just a little bit simpler API. So that's about the body. The second thing is preferring no effect modifiers over conditional views. That's a very long title, and we're going to break it out. So in this example, we have an age stack, and we maybe are presenting a cupcake view. If we take that hierarchy and we look at the view tree of what we get from that hierarchy in SwiftUI, we have an age stack. On the right, we have whatever other views we have in there, and then on the left, we don't have cupcake view. We have optional wrapping a cupcake view. This means that we maybe have that view in the UI hierarchy, and we maybe not have that view in the UI hierarchy. And that, one, it can hurt performance, and two, it means that SwiftUI does not know how to animate between changes. So if you present or not present that cupcake view, SwiftUI wouldn't know how to change how to do the transition correctly. Usually it guesses if you do with animation, and it might look fine, but it might not be what you want. This is even worse. This, you might say, oh, when I don't have the cupcake, I want to present it kind of like disabled with only half the opacity. Now you actually have two views in your hierarchy, right? So this is not like creating a UI view where you maybe create this UI view, maybe create that UI view, and only one of them exists. In this case, you have both in the UI hierarchy. I'm sorry, in the view tree, and both exist at the same time. If you have any state that you want to keep, they don't know about each other's state, so you might have unexpected behavior also here. And this is just really not the way to go. SwiftUI also cannot animate between them because SwiftUI has no idea that it's actually the same thing in your mind. It can only remove one and add the other. So what you want to do is, this is what's called no effect modifier. So for example, opacity is a value between 0 and 1, and if you provide 1, this is like not providing the opacity modifier, right? And so you do the condition inside here, and you either provide opacity 1 or opacity 0. Now you can see that the view tree is much more simple and much more, it's much closer to what you expect in how you view your UI of your app. You have an age stack, and you have whatever on the right, and then you have the opacity modifier and the cupcake view, and that's it. And then also SwiftUI knows exactly how to animate between the changes. If you have any state changes, those state changes inside the cupcake view, they stay because the cupcake view is always in the view tree. If you are a little bit confused by this and you want to learn more, there's a really, really good WWDC 21 talk, Demystify SwiftUI. Highly recommend it. And if you are thinking, oh, I'm never going to watch it, just no way, 21 is way too old for me. Here is maybe the most important quote from that talk by Raj. He gives some example. You see opacity 1, padding 0. It's basically no effect modifiers. And he says, when you introduce a branch in your views, like we saw with the two cupcake views, pause for a second and consider whether you're representing multiple views or two states of the same view. And I think that's kind of like the key. If in the end it's the same view, but it's just two different states, don't branch. And then there is another thing that these conditional views create. And this is something that was, I'm not sure if it was public. I think it was private. There was like a great blog post about it. I'm going to give you the link in a second. But then in this WWDC, Apple officially talked about it in one of their talks. And I think it's really, really important. And that's the idea of view size. So view size is not size in terms of XY pixels, points. It's the size in terms of how many views we have in the hierarchy. So in this example, we have a list, and we have these items. And each item is a size of 0 to 1, which means each item is maybe text, right? Because if the item is empty, we don't show the text. If it's not empty, we do show the text. So we cannot know ahead of time how many views we're going to have in this list. Specifically with lists, this is a very big problem because you think that list is lazy, and if you have many items, it's going to load them lazily. If your view size inside the list is not known ahead of time, for example in here, list is going to create all the views in your for each, basically create all the views for every single item when you show that view on the screen, even if you have 1,000 or whatever, however amount you have, because it needs to know how many views are in the screen. And so this is really, really bad for list or for lazy VStack, lazy H stack, or any lazy stack. Something you can do, again, like I said before, like you saw a second ago, you can use opacity, 0 or 1. The problem here, well, first of all, then you get size 1. Perfect, great. Now list is actually lazy. The issue here, maybe you already guessed it, is that, oh, well, it's on the screen. Empty items will get a row too, so you will just get rows with nothing in them, because now you always have a text, but it may have opacity 0, right? So this is going to look very bad. You're going to have rows that you just don't want them. So what you probably want to do instead is you probably want to filter the items first and only provide the items that you actually want to create rows with. And then the number of rows is known ahead of time. The size is 1. And you're never going to have empty rows. If you remember what I said about complicated bodies and keep view bodies simple, then you might say, oh, but this filter might be complicated, and you're right. And if it is complicated, this filter, and it's not easy and quick, then you probably want to filter it somewhere else in a task, async, and then only when it's filtered, provide it to the list. Those are the 2 links that I said. So this is the blog post by Renz. Incredible blog post. Highly recommend reading it. And if you hate reading, then Demystify SwiftUI Performance from WWDC 23 goes very deep into this. And it's a really good explanation. Highly recommend. So that's about that. The next thing is splitting state into custom view types. So here we have some big view, and we have some very long body code. And you can see that the body is using different parts of the body is using different pieces of the state of that view. But whenever, because it's all in one body, it's all in one view, whenever each of those items, each of those variables changes, we are going to re-render or at least diff this entire body. And this might be very complicated. For example, we might have this huge body with a bunch of stuff. All of this is going to be diffed when anything changes in that view. You might think, oh, I'm going to move them into variables. Not going to help. This is exactly the same. As far as you care, I mean, the compiler might even inline that. Who knows? And so this is exactly the same as what you saw before. It does nothing. What you can do, however, is you can move them into their own subviews. So it looks almost the same, right? But here, if you think about that, when you call the body of the large view with the 3 subviews, you're not calling the bodies of those subviews. You're only creating them. And like you saw in the beginning, when we create them, the first thing we do is we compare the state, right? If the state is the same, we don't even bother calling the bodies of those views. And then we get a diffing that is much faster, and we avoid diffing, let's say the red variable change. We don't even bother with the purple and the green. And then the body of the view is now much smaller and much simpler, much easier for SwiftUI to handle and to diff. The last thing I'm going to talk about is POD and equality. POD stands for plain old data, and this is a little bit complicated. Also, spicy section warning. So yeah, some disclaimers. First of all, none of this is part of the official SwiftUI API. So you're not going to find any documentation about it, only some tweets from random Apple engineers on Twitter. I'm going to show some underscore functions. Do not use them in production. Apple will not like this. Any of this might change in the future, so you might see this today, and 17.1 comes out, and none of this is true. But it's been true since iOS 13, so hopefully it's pretty solid. And I'm not a tax advisor, so this is not tax advice. So when we compare views, there are 3 methods that SwiftUI is using to compare between different views: memCompare, equality, and reflection. And there are a few things that to determine which of those actually happen. memCompare is a C function that compares the actual bytes of the struct and literally just compares the memory between the two structs, the old state and the new state, and comparing whether they change or not. This is by far the fastest way to compare between the states of views, and this also means that obviously this is what you want to have. Equality is a little bit slower, but it's still OK. And that only happens when you implement double equals in your view. And also, you will see in a second in a few other things. And then reflection is kind of like the fallback default, and it's the slowest way to compare between between two views. So if you have any performance problems, you might want to try to make it use memcompare instead of reflection. So first of all, what is a POD? POD is a view that is just kind of like a bag of variables, essentially. You can see on the left, it's some string and another string and some int, and that's about it. On the right, you have an example for a non-POD view, which is this very complicated view with a state and a binding, an environment, and all that stuff. It's not that clear-cut, because again, it's all private stuff, and so it's sometimes a little bit unclear if your view is POD or not. Thankfully, there is a function you can use to ask the system at runtime whether it's a POD or not. So you can just call this check underscore is POD, pass the class of your view. You don't even need an instance of that view, because it's based on the definition of the struct of the view. And you will get a true false. And you can know if it's a POD or not. So what is used when? This is complicated, so I have 3 ways to show you the exact same thing. Pick the one that is the least confusing. So the first one is POD views always use memcompare, the fastest one, unless you wrap it in equatable view, essentially forcing it to use equatable view. Why you do it, I'm not sure. Maybe you have some weird logic and you really need to use equatable, like a custom double equals function. If you do not wrap it, it will always use memcompare. Non-POD view will always use reflection unless it's conforming to equatable. So in the case of non-POD view, you don't even need to wrap it in equatable view, because as soon as you implement equatable, SwiftUI is already like, oh, this is better than the reflection I can do, so I'm just going to use the equatable you gave me instead. So I think this is the easiest way to remember that. But if you like graphs, this is a graph. I think it's horrible, but it's showing exactly the same thing. You ask whether it's a POD, yes or no. Is it equatable, yes or no? Then it's going to either reflection or double equals. And then if it is a POD, wrapped in equatable view and equatable, then double equals. Otherwise, memcompare. A third way, and I think the most important part in this table, again, it shows exactly the same thing. But the important part here is that for a POD view, you will never get reflection. So that's why you want to strive to have your views be POD. And for a non-POD view, you will never get memcompare. The best you can do is conform to equality, and then you get double equals called instead. Yes, if it's confusing, I agree, 100% it's confusing. Another way to look at it is equatable. The conformance to the protocol lets you avoid the slow reflection, right? An equatable view, when you wrap your view in equatable view, that lets you force the double equal instead of the memcompare. What can we do about it? So there is a way to kind of like trick SwiftUI while still avoiding custom equality, because you might think, oh, I don't want to use custom equality because I implement double equals, and then I add some dependency or some state to my view, and I forget to add it in the equality, and then my view does not get refreshed, and I have no idea what's going on. And I agree, double equals definitely has that risk, and you should avoid it if you can. So there is this trick that we've been using in Bēhance very successfully to avoid custom equal, but still get a POD view for heavy views, for views that are very heavy to diff. And the idea is that you split your dependencies from the state, right? So dependencies are things that the view needs, and state are the things that the view declares and handles itself. So let's imagine this scenario. We have some expensive view, and it has some value. That's the dependencies, right? It gets passed from above. And we have a model, that's the state. that we create and we handle and nobody else even cares about, so it's even private, right? Which is good practice regardless, to put your state as private. This is a non-POD because we have this state. And so it does not use memcompare. But maybe this view is very expensive because of whatever reason. We do like, I don't know, we grab an image from cache and it's very heavy. So what you can do is you can take your expensive view and create a new view, and you can even make it private actually, because you only use it inside that file, and you can call it like expensive view internal or whatever you want to call it. And inside the internal version, that's where you have the full view with both the dependencies and the state, and it's still non-POD. But then the public view, expensive view, right at the top, that one is now POD because we dropped the state. So that thing now only has dependencies, a simple int, nothing else. And from the outside, from the parent is going to be the parent of expensive view. And that parent is going to compare this tiny int, and that's it, and using memcompare. And you have very fast equality. Only if that is different, only then we have to render expensive view internal and refresh that. And obviously, because state handle itself, so if the state actually changes, then expensive view internal will re-render itself because state changed. So to summarize, keep your view body simple as much as you can. Prefer no effect modifiers over conditional views. Split your state into custom view types. And when needed, utilize POD or equality. And obviously, I'm not expecting anyone to go and do like _isPOD for every single view in your app. It's never going to end. But if you have a view that's for some reason, it's a pretty heavy view and it's doing something complicated, and you want to see what's going on, you can definitely look into that and try to debug that and maybe see if you can find a clever solution. So this is one piece of what can help you achieve great SwiftUI code base in your app. The other two pieces are behavior and structure. Right? So we have behavior, structure, and performance. And the first one, behavior, is about code correctness, which is make the code do what you want the code to do, what you think the code should be doing. Structure is the layout, where do you put each piece in the code base, how to build the body. In the end, in my opinion, it makes your code more flexible, easy to read, and maybe most importantly, easy to delete, because we need to make changes all the time. And then performance, which we talked about today, is to compile fast, to run fast, and to increase stability. And so during my last 2 years, I've been working mostly with SwiftUI at my job. We got pretty deep in SwiftUI, and we learned a bunch of things. A lot of things that you should avoid, a lot of things that you should make sure you do. I was also extremely fortunate to work with Dave Abrams. It's the guy from Krusty, if you don't know, who worked on the SwiftUI layout engine and now works at Adobe. And so he helped me create this guide that is a collection of best practices for SwiftUI, and it's mostly things that we didn't see anywhere else online. I think now Apple started to add a bunch of stuff that are actually were in that guide. But this is kind of like a live document that we created maybe a year ago, and I still update that all the time. And that document is part of a tiny blog website I made that has, other than this document, it has a few more other things about SwiftUI, tips and tricks that I just couldn't find in other places online. It's not like a tutorial website. It's mostly tools and explanations that were difficult to find online. And that guide has everything I talked about here and way more things that I did not have time to talk about. So I highly recommend checking it out. And that's it.